Woohoo! It looks like we're live. Woohoo! This is Math 60. This is the 483rd page of section 4.1 on inequalities. And we are almost there. This is the last page. I'm very excited. I hope you're very excited. I'm going to pretend like I'm not going to just turn around and start 4.2. But here we go. Now, this is an exciting problem. This is supposed to be very, very difficult. It hopefully is not actually, but it's going to look very difficult. It says, let f of x, oh my gosh, we've already got function notation. F of x equals -3 times the quantity x plus 8 minus 5x. And g of x equals 4x minus 9. It's slightly easier. This one's got its stuff together. Again, what is it with these functions that just have their stuff all over the place? I don't know. Some good therapy would be helpful. You are supposed to find all x for which f is greater than g. This seems so complicated, but it's just substitution. I'm going to take my f of x, the -3 times the quantity x plus 8 minus 5x is greater than, and then we're going to take the g, 4x minus 9, and that's it. Bam, we solved this inequality. So hopefully it's not as bad as you worried, but possibly worse than you hoped. I'm going to go ahead and try to figure out f stuff here. It's a -3x minus 24 minus 5x. F is having a bad year. Look at all those minuses. I've got a -3x and a -5x, so I got a -8x minus 24 is greater than 4x minus 9. Oh my goodness. Again, at this point, I'm going to encourage you to stop the video because you guys have control over this. That was funny. That was me pretending you stopped the video. Okay, so you can stop this video and go ahead and solve it the way you like, because there are two ways to solve this. And one is to go ahead, throw caution to the wind, bring the 4x over here, deal with a minus because it's no big deal. Or throw the 8x over on the other side because you can flip things around. That's no big deal. So whichever way you prefer, you should go ahead and follow through. What I'm going to go ahead and do is I'm going to move the x's onto the left because I think that is more common and I want to give you practice for the folks who are more of the folks are probably going to do it this way. So I'm going to subtract 4x from both sides. I get a -12x minus 24 is greater than -9. So far, so good? Okay, let's see if I can squeak out a little bit of space over here because I did not plan this as well as I had hoped. I'm going to go ahead and add 24 to both sides. Yay. Now, inequality, when I add to both sides, when I subtract from both sides, no big deal. The inequality does not change. Oh my gosh, -9 plus 24, I think is 15. Let's hope it is. You know what? I'm the math teacher. Let's just say it is. And you know, who's going to check? Next up. Oh, dun, dun, dun. I'm going to divide by -12. You know what that means. Dun, dun, dun. I have to pull out my really cool brand new yellow highlighter. Look at that beautiful thing. And I'm going to say if I divide by a negative number, that inequality has to face the other way. So x is less than 15 over -12. Now, you're going to think we're done. We're not done because math is never that easy. There's a reason people in grad school cry. So I noticed that 15 and 12 are both divisible by 3. So I'm going to go ahead and reduce. X is less than 3 into 15 goes 5 times. 3 into 12 goes 4 times. And we're done. So when is it true that f is greater than g? F is greater than g when x is less than -5/4. There you go. Woohoo. Next up, some weird philosophy stuff. A note, mathematical statements are very similar to English statements. They can be false. I mean, they're cooler than English statements, but you know, your English teacher doesn't want to admit to it, so we can just know it. So I can say, your teacher is an eggplant. Now, assuming your teacher is me, I'm not an eggplant. This is actually false. I am not an eggplant. I know some of you had suspicions, but it turns out I am not an eggplant. So, what we can do though is I can give you a couple of problems and ask you if they're true or false. So, for example, 3x is less than 3x plus 1. Well, how would we check that? Well, I would need to try to solve this inequality, which would require me to combine, get all the x's on one side or the other. Now, your lizard brain is going to go, oh no, oh no, oh no, 3x on both sides. Don't sweat it. Remember, the rules are about math is just follow the process. Just trust the process. Don't panic. Don't try to do the problem 3 steps ahead. Do the problem we've got. Do the problem you have, not the problem you'd like to see, or something like that. I'm going to move this 3x over to the left by subtracting 3x. Now, what's going to happen? Do not panic. Tell your lizard everything is okay. There will be some lovely berries or bugs or whatever the lizard wants to eat as soon as we're done with this. I'm going to subtract 3x from the left. I'm going to subtract 3x from the right. This is going to leave me with 1. And because it's subtraction, I'm just going to do a less than. Is 0 less than 1? You're right. This is true. So this is a true inequality. Now you could pretty much guess what B is going to be. I mean, I'd have to be, like I don't know. I'd have to be like an evil genius to give you 2 that were true. So you could probably guess that B is false, but let's see why. I want to know if 3x could be greater than 3x plus 1. Now, if we stop and think about it, if I have a thing, 3x, and then I add 1 to it, that's not going to be smaller. If you add 1, it's going to be bigger. So this just doesn't even make any sense to begin with. But let's go ahead. Again, calm your lizard brain. Let's say I'm going to move this 3x over to the left by subtracting from both sides and go, oh no, it all disappeared. And then I get 0 is greater than 1. Now, is 0 greater than 1? No, this is false. So, what does your answer to the second example mean in the context of the equation as a question? This means there's no solution. If we get a statement that is false, no value of x, and you could try a bunch of different x's, no value of x can make this statement true. On the other hand, part A, it doesn't matter what x is, it's always going to be true. So this is true for all values of x. So this would always be true. Woohoo, you've done it. You've made it through 4.1, and I'm very proud of you. Little spider who has gone on walkabout is very proud of you. Here's little spider. Yay, you made it through 4.1. And we're going to pretend like we're actually going to, eat and sleep and exercise, and then I'll see you for 4.2, possibly even in another couple seconds. Bye.